Hello guys and gals, it is I once again, Coach Goo, with another fun-filled, action-packed, flipped geometry classroom video. Today, our notes cover the ever amazing quadrilateral that is called a trapezoid. So today we're gonna learn about normal trapezoids and isosceles trapezoids. So let's take a look at them. So for non-isosceles trapezoids, we've got non-isosceles and isosceles. Let's read this together. So for non-isosceles trapezoids, I'll highlight where I'm reading. Only one pair of opposite sides is parallel. Only one pair of opposite sides is parallel. You can see in our picture right here, these two lines, the top and the bottom, those are the parallel lines in this trapezoid. There's only one pair in a non-isosceles triangle. Alright, then it says that consecutive angles are supplementary. Let me change that from consecutive angles and make that say same side interior angles are supplementary. That makes a little bit more sense. Remember, if we have two parallel lines, as stated in the first rule, the top and the bottom, and we have a transversal that cuts through them, for example, this one over here, then these two angles, 1 and 2, those two angles are the same side interior angles. They're going to add together to be 180 degrees. Now also there's another pair like that over here, bam, and angles 3 and 4 would also be same side interior angles, and they would add together to be 3. They would add together to be 180 degrees. Okay? So those are the two properties of non-isosceles trapezoids. Moving into the isosceles trapezoids, remember, when we had a triangle, we had normal triangles like this, but then we had isosceles triangles with two congruent sides. Remember, like this, oh my goodness, two congruent sides. Well, it's the same idea with trapezoids. We're gonna have non-parallel sides that are congruent. The non-parallel sides are congruent. Remember, we have two parallel sides in a trapezoid. So in this picture, it's going to be the top line and the bottom line. These two sides are parallel. So the non-parallel sides are going to be congruent. In this picture, it's going to be this side right here and this side right here. These are congruent. That's going to make it an isosceles trapezoid. Well then, if those two sides are congruent, then the diagonals are also congruent. That's going to be this line right here and this line right here. Boom. Those diagonals will also be congruent. Next, the base angles will be congruent. That would be the angle right here and the angle right here. On the base, those two angles are congruent. And I guess you can say these two as well. This angle and this angle will also be congruent. And finally, opposite angles are supplementary. That means if we take the two angles that are across from each other, so this angle plus this angle right here, those would add to 180. And then also this angle plus this angle right here, those would also add to 180 degrees. Okay, so those, bam, bam, 180. Those are the properties of isosceles trapezoids. Alrighty, let's go through some examples to really see how we use these properties of trapezoids in questions. So, number 1, take a look at this. First of all, is this a normal trapezoid or is it an isosceles trapezoid? This one would be a normal trapezoid because the two non-parallel sides are not congruent. This one and this one, not congruent. So we need to find the measure of these angles. They're looking for measure of angle K, and they also want the measure of angle M. That's right here. So how would I find that? Remember the same side interior angles. That would be boom right here, and then boom right here. Those two angles are always going to add up to be 180. So if you take a look on this side, K plus L, so measure of angle K, measure of angle K plus measure of angle L equals 180. Well, what's the measure of angle L? That's 51. So the measure of angle K plus 51 equals 180. If I subtract 51 from both sides, then the measure of angle K equals 129 degrees. Bam. And then the same thing with the other side. This 87 plus the measure of angle M equals 180. So I could just take 180, subtract 87, and that gives me the measure of angle M, which is going to be 93 degrees. There you go. Very simple. Number 2. This one. Is this a normal trapezoid or an isosceles trapezoid? Oh my goodness. Look how they've shown me that these two sides are congruent. That's going to be an isosceles trapezoid. It's got to be. All right, how am I going to find all the angles here then? Well, first of all, I should know that the base angles are the same. So, measure of angle P is going to be congruent to measure of angle Q. That's right. So, measure of angle Q is also 112 degrees. And then I should be able to use that information to find these bottom two angles. If the measure of angle P is 112, well, this P plus the S down here is going to equal 180. So if I just take 180, subtract 112, that will give me my missing angle S, which is 68 degrees. That's going to go to S. Bam. Because 68 plus my 112 equals 180. So measure of angle S is 68 degrees. But then, because it's an isosceles trapezoid, measure of angle S is also equal to the measure of angle R. That's right. So measure of angle R is also 68 degrees. There we go. Oh my goodness. Moving on. Number 3. Oh my. Those aren't even numbers, Coach Goo. Just give me number. Nope. Now are you going to use some algebra to find our angles? Remember, the two same side interior angles, or the consecutive ones, bam, these two add up to 180. So what equation could I write to set up to find x, which is going to eventually give me the measure of angle r? So I can write, I can't even see it because I covered it up, but it's going to be 12x plus 3 plus this angle down here, 7x minus 13 equals, what do they equal up to? 180. That's right. So first, combine your like terms. 12x plus 7x. That's 19x. Bam, bam. 3 minus 13. 3 minus 13 is minus 10 equals 180. Next, I'm going to add 10 to both sides. Boom. 19x equals 190. That means I'm going to divide both sides by 19. And x equals 10. But that's not my answer. They want to find the measure of angle R. I only found x. Measure of angle R is 7x minus 13. X now I know is 10, so I can substitute that in. 7 times 10 minus 13. So that's going to be 70 minus 13 equals 57. The measure of angle R is 57 degrees. Boom! Number 4. Look at, wow, they told me some information. This is an isosceles trapezoid. That means that, bam, this side is congruent to, boom, this side over here. JM congruent to KL. Find the measure of every single angle. Oh my goodness. First of all, I'm going to have to find x. Now, what equation could I write to find x? It's the same idea. You can take this angle right here, J, plus the measure of angle M. These two should add up to be 180. That is correct. Oh my goodness. So we're going to write 10x minus 33 plus this angle down here, 4x plus 17 equals 180. First, we're going to combine like terms. 10x plus 4x. That's going to be 14x. Negative 33 plus 17. That's like the same thing as 17 minus 33. That is minus 16. Equals 180. Then we're going to add 16 to both sides. Boom. 14x equals 196. And then we're going to divide both sides by 14. And if you did that, clearly stalling because I'm getting my calculator out, that would be 14. So you're going to divide both sides by 14. Boom. And x equals 14. But that's not my answer. We're looking for all 4 of the different angles. Now remember, because this is isosceles, well, first let's just find measure of angle J. So measure of angle J is, that's right here, that's 10x minus 33. But I know x is 14, so I'm going to plug in the x. 10 times 14 minus 33. That's 140 minus 33. That's going to be 107. So measure of angle J is 107 degrees. But measure of angle J is the exact same as which other angle here in this isosceles trapezoid? That's the same as measure of angle K. So the measure of angle K is also 107 degrees. Now, instead of plugging x back in, I can just take I can just take these two angles, and if I want to find m, I can just subtract j from 180. Remember, because they add up to 180. So 180 minus 107, that's going to be 73. So the measure of angle M is 73 degrees. So since I found the measure of angle M, that's 73 degrees. Oh, what's this? 73 degrees. That's also the exact same as the measure of angle L on the isosceles trapezoid, which means measure of angle L is also, oh, I wrote it in the wrong spot. Anyways, 73 degrees. There you go. They're the same. That's the isosceles trapezoid. All right, guys, I want you to look at number 5 and do number 5 on your own. Use the exact same properties. Number 5 is a trapezoid. They just tried to mess you up by drawing it in a funny way, but look, you could flip it around and just draw it like this. Boom. Parallel. Parallel. And then this 54 is right here. And then I'm going to draw an arrow. 8x plus 6 is right there. So this is actually just another trapezoid. They just flipped it around to make sure, you know, to test you and see if you could actually understand that it's still a trapezoid. Use the same properties we've been using to solve for x. Okay? And then looking at number 6. Number 6 is an isosceles trapezoid. What does that mean? That means MP is congruent to NO. Okay, and then we got the base angles are also congruent. Let's see all the information they gave us and see what we're looking for. MP, get out of there. MP over here is 16x minus 13. All right, NO is 9x plus 8. Okay, cool. Then they tell us that PN, that's this diagonal. I'm going to label it with the orange. PN right there. They told me is 5y plus 19. And then they told me MO, that's this diagonal right here, is 12y minus 37. Now remember, on the isosceles trapezoid, the two non-parallel sides are congruent. That means MP is congruent to NO. So if I want to set up an equation to solve for x, I could say 16x minus 13 equals 9x plus 8. From there, I'm going to subtract my 9x from both sides. That gives me 7x minus 13 equals 8. Then add 13 to both sides. 7x equals 21. Then divide both sides by 7. And x equals 3. So I've solved for x. Now I want you guys to set up the equation for the diagonals and solve for y. And that's going to be the end of our trapezoid notes. Oh my goodness, we finished yet another quadrilateral. I think we've only got one more. So until then, see you in the next one. Peace!